If you state that it's unlikely we'll ever colonize the moon or Mars, why do you think that?
There have been no studies, of course, with developing fetuses, for example, pregnancy in space, but we can assume that we'd want that to happen.
How would we do that? Would we land physically on the asteroid to extract its minerals, or how does that work?
And you can rotate the cylinder, depending on the diameter, at various speeds to create one gravity.
But do you think that the move towards a global government is politically dangerous in any way?
These were intended to replicate a space colony and put humans in an enclosed, glass-enclosed environment. It was a glowing disaster.
Welcome. We are back for another episode. To all our subscribers, we just thank you guys for your support. If you haven't subscribed, please click that subscribe button, the follow button, the like button, wherever you're watching, wherever you're listening to us. Show us some love, and we really appreciate it. Today, we're putting on our science fiction hats, and we're going to talk about space colonization. So what does the future hold for humanity? Is human colonization in space a reality? Is there life in the universe beyond planet Earth? Well, our guest today is an author and molecular biologist who's studied these questions and others, and today we want to pick his brain and get his thoughts on these issues and more. Please welcome Richard Anderson. Richard, thanks a lot for being here today.
Oh, it's a pleasure to be here.
So in your book, The Evolution of Life, you state that it's unlikely we'll ever colonize the moon or Mars. Why do you think that?
Well, I've sort of changed my thinking on that a little bit, but the obstacles to living anywhere in space, anywhere off planet, are tremendous. And from a biological standpoint, from a social standpoint, from any way you look at it, we have spent 3.5 billion years evolving on this planet. We've adjusted to we've evolved to live in this gravity. We've this atmosphere, everything about the Van Allen radiation belts protect us from cosmic rays and so forth, from our sun, the nearest star, and from elsewhere in the galaxy. There are lots of cosmic rays out there. Cosmic rays are most likely protons, neutrons. They're particles. They're not really rays. So they cause, and they're traveling at near light speed. And so when they impact something, if you can imagine someone throwing a hard ball as hard as they can, 100-mile-an-hour hard ball, and slamming into your body or slamming into a spaceship, that could be a proton traveling at near light speed. So in other words, it's very hostile out there. So I wrote the book to really study evolution and how we got where we are, and to project where we might be going in the future. And then toward the end of my book, I talk about the social implications, the development of societies, and some of the issues that we have on Earth today in societies, mainly with aberrant behavior, terrorist, just basically any kind of aberrant behavior. Earth is a big place, so we get away with a lot of abuse on each other and on the planet. We have so far. So my secondary message is one of ecology. But so it's a big place. You live in space, you're going to be in a confined environment. You're going to be in, and I chose rotating cylinders to create one gravity on the inside edge of this cylinder. It's called centripetal force. And you can rotate the cylinder, depending on the diameter, at various speeds to create one gravity, which is important for us to live in and to grow in. There have been no studies, of course, with developing fetuses, for example, pregnancy in space. But we can assume that we'd want that to happen at 1 gravity. We don't know what would happen if the pregnancy went through at 0 gravities. So there's a major issue with the moon, which is 1/6 gravity, and in space colonies or in space environments, habitats, you can create 1 gravity by this rotation, and on a planet or a moon, it's a lot more difficult. So that's the first step. Secondly, is we would have to bring our Earth environment with us as much as we could. We'd have to duplicate that in space. Now that's possible within these rotating cylinders. Difficult, but possible. So we think of engineers as the people leading such a population in space. We think engineers and scientists would be the vanguard for developing habitats in space. But probably the more important people would be the biologists and the microbiologists and the ecologists and environmental people who understood these complex systems and could develop and replicate them in space. Not an easy problem. I think what's the name of the Biosphere 1, Biosphere 2, you may be familiar with that. It happened a few decades ago. These were intended to replicate a space colony and put humans in an glass enclosed environment with, they would grow their own food, they'd be 100% self-sufficient. There was supposed to be, there were a lot of things to try and assure that this was going to be self-contained. It was a glowing disaster. Biosphere 2, when they finally exited, I don't remember how long, it was supposed to go on for a couple of years, I guess. And when the people finally exited, they'd lost a lot of weight. They weren't growing enough food, enough calories to keep them going. Socially, they had basically divided into 2 groups. I think there were 8 people, 4 females, 4 males. They divided into two opposing groups of people. So it failed on in a number of respects. So the social issues are a major concern, knowing how flawed we are as humans.
Yeah.
So
we can't even get elections right. At least here in the U.S.
Yeah, I mean, and you look what's happening around the world. There's a pendulum, so we're on a downswing now, I think, and hopefully we'll be on an upswing. But I remember at the dissolution of the Soviet Union, there was a lot of hope. The Berlin Wall came down, and we thought, wow, this was a world-changing event. The Arab Spring was another world-changing event, and I think it did advance, and it retreated a lot, but I think the net effect was there was some advancement. Many of the countries that spun off of the Soviet Union became democracies, and they're still struggling. So, there is progress, but like I say, Earth is a huge place. Yeah. We can have migrations. You don't like a country or the politics, or you're persecuted, you can leave. Hopefully, you can leave. You don't have that option on a space colony or a space habitat. So
it's a good point. I never really thought of that aspect.
Yeah. So my concept when I ended my book on evolution, which is a science book, I projected a couple of chapters in what's the next step? How to survive long term, we're going to have to we're going to have to address the problem of living off planet, because number one, our planet's not going to live forever. And so if you're looking really long term in a billion or 2 years from now, who knows what will happen? But if mankind is to survive itself, we need to be able to become spacefaring people or a civilization. So I kind of discussed some of the actions that are happening today in that realm in my science book. Well, then that was a jumping off point for my science fiction book, which is Outbound Islands in the Void. So I dropped the idea of colonies, because these islands in the void, these islands that would exist out there, would become independent of Earth. Earth would not be in a position to really manage off-planet civilization. They would have to manage themselves. And the idea was you cannot transport, the first idea is you cannot transport everything that's needed from our planet, from this gravity well. You can't launch the amount, the mass of materials needed to build, say, a rotating space colony or island that's maybe 2 kilometers in diameter and maybe 20 kilometers long. Now, you think by Earth terms or by spaceship terms, that seems really large. But if you're putting a settlement in there, imagine yourself living in that kind of a confined environment. You're limited to 20 kilometers in length. So my idea is you would build a cluster of them, and you would build them in a gravity neutral orbit, which would be a Lagrange point. My first one was Lagrange, Earth Lunar Lagrange 0.5, and Earth Lunar Lagrange 0.4. These are the two balance points in orbit in the moon's orbit. Anyway, they're balance points. One trails the Earth's orbit, and one balance point leads the Earth's orbit. So you would build a series of, say, 6 of these rotating cylinders, and then you would have a construction, maintenance and construction facility that would be the 7th facility, and they would all be clustered in these 2 balance points. And the construction facility would be largely robotic controlled, and you would build components to build these huge cylinders. And you would get the materials initially from the moon. Now, NASA has planned a moon base at the south pole of the moon, and that's China's looking at that location. Any nation with aspirations for occupying or putting a base on the moon is looking at the South Pole because that's a source of water. And
there's only water at the south pole of the moon?
Well, easy accessible water. Mm-hmm. So because it's the South Pole has a crater, and within the crater it's in perpetual darkness down inside the crater. So it remains frozen, and they've detected, significant water there, enough to support a base, for example. And also the location would be good for solar collectors. You would put those up around the rim of the crater at the South Pole. So NASA has its eye on the South Pole if they ever get Artemis off the ground. And from there, they would build what's called a mass driver. And these are electromagnetic motors, linear motors. So they have a series of magnets on a track, and you have a cart that you put your payload in, and you accelerate it down this track. And from the moon, with 1/6 gravity, you can launch things into orbit. So you would set up a mining colony there and process as much as you could and develop and build, say, structural components for these colonies, and you would launch them into orbit, and they would be picked up by orbiting spacecraft and so forth, and taken to the lunar the L5 or L4 position to begin construction. And you would be building. You would have your Mac facility. Anyway, that was how you would get a start. Then you would put a habitat out orbiting Ceres, and Ceres is a planetoid asteroid in the asteroid belt, and there are basically three main asteroid belts, and they're gravitationally separated. So your closest asteroid belt is they're called S-type asteroids. They're regolith. They're made out of rock and basically what the moon is made out of, and Earth. And the second belt is the M asteroids, M-type asteroids, and they have a higher metal content, nickel and iron mainly, and a lot of water. They found water on Ceres, frozen as ice. And the outer belt is called the C-type asteroids, and those are carbonaceous. They're like big lumps of coal.
These are all raw materials that we would use to manufacture parts and components.
So if we had a facility, say, orbiting Ceres, and that could process these asteroids, and we had...
How would we do that? Would we land physically on the asteroid to extract its minerals, or how does that work?
I have some diagrams in my book. There is a diagram on the back cover, actually, if you looked at it. It shows these spaceships with big arms on the front, and they're piloted. They could be robotic. Some of them would probably be robotic, and they would go and grasp the smaller asteroids and tug them into a position near a processing facility out at Ceres. So they would travel around the belt and looking for particular types of asteroids. They would be cataloging, and then they would either break them up and enclose them in a mesh to attach rockets to, and put it on a path to Lagrange point 5 or Lagrange point 4 to be picked up. And so I describe how that would happen and how dangerous it is. You're sending these...
I was going to say, that's dangerous, right? Those things are moving pretty fast.
Closer to the Earth's gravity well, and you don't want to make any mistakes. And so the people that would be in, say you're sending it to LL5, and I've abbreviated or I've humanized the name by calling it LE5.
And what is that? Is that a base or is that a craft? What is LL5?
That's a position. That's your Earth lunar Lagrange point 5 and Earth lunar Lagrange point 4. I described, in fact, there's a diagram of the Lagrange points in my science book, the first book of evolution. There's a diagram that I got from NASA that shows there. A Lagrange point is created when you have a smaller body orbiting a larger body, and within that orbital path, there will be positions where the orbiting, when an object is in orbit, it's creating a centripetal force outward to counter the body's gravity force pulling it inward. And so that's what satellites do, is they spin around the Earth at a speed that's significant enough to counter the gravity. So you can have satellites at different altitudes, and uh, the closer they are to Earth, the faster they orbit. So if you've ever seen the space station fly over, doing a flyover at night, and you can see it with your bare eyes, with your naked eyes, you can see this thing. It moves pretty quickly. It's
Mhm.
only a couple hundred miles up there. It's very close to the Earth, 200 to 400 miles. I think it varies a little bit. So if it's at if it's at the if it's at the let me see on the geostationary or geostationary orbit, which means the satellite will sit over one site on Earth. Then it's orbiting at the same speed that the Earth is rotating. And on Earth, that's around, I think, around 22,000 miles out there, 17,000 to 22,000. I don't remember the exact number. It's quite far out. Um, on Mars, it's going to be 17,000 kilometers, so about 12,500 miles out from the planet. It will be in, and there they call it aerostationary orbit to distinguish it from geostationary orbit, which is around the Earth. So it's like you take a ball on a string and swing it around your head. Um, Kids have all done
Mhm.
that.
Yeah.
So it's a good exercise to understand centripetal force. So that's what orbits are, and these are balance points. The Earth lunar Lagrange points are the system of Earth and the Moon. But there's a Earth solar Lagrange points, which are the same, except Earth is orbiting the Sun, so there. It's the same mathematics, in other words. So
Hmm.
that's where you would put your first colonies, your first habitats would be in these balance points. They're not perfect. They do take a little bit of energy to sustain objects there, but they're close to perfect. And if you can think of them as a mountain, and there's a little flat spot on the peak of the mountain, and you put a ball bearing, or you put a big wheel up on the top, or a big sphere on the top of this mountain. As long as it sits on that flat plane on the in the center of the mountain, or anywhere on that flat plane, it'll be in balance. As soon as it gets to the edge where it starts to slope off, it's going to fall out. It's going to leave. It's going to. That's an analogy. That's a diagrammatic analogy to what these sites, what these Lagrange points are. They're gravity
Okay.
balanced places. That's a way to visualize it. So,
So, like, I want to just circle back. That's a lot of information and it's helpful in just kind of visualizing how this would work. But circling back to, you're a molecular biologist, so I'm wondering if you can speak to the health implications of that. We have to simulate the gravity we have on Earth. If we don't have that same gravity one, do I have that
yeah,
right? Yeah. So if we don't
standard. It's
duplicate,
called standard gravity. Yeah,
right? Okay. So if we don't duplicate standard gravity, what we're designed, accustomed to living in, we'll start experiencing things like muscle atrophy and there's no resistance. So is that what happened with those biosphere projects where they just did they emulate the right level of gravity? You said people came back sicker and kind of
no,
malnutrition. What happened?
the biosphere was on Earth, so it
Okay.
was at one. It was at standard gravity. So the failure there was with the biology, with the ecosystem. It wasn't substantial enough to support the humans, and they did not take into account, potential social issues. So possibly they could have done some very intense screening to see if the people were all more compatible, maybe than they were. And we were at that time they were pretty naive about things like that, and um,
Understandably, there's a
yeah,
lot to
of
consider,
course.
right?
I mean, I can't
Yeah.
imagine myself, being stuck in a thing like that for a couple of years with seven
Yeah.
other people, and
I never thought of that until I read through your book and realized there are social implications to this too.
so. But the adverse effects, a lot of them have been studied on the space station by NASA and other countries, but where they put people up for a year or plus. And the Kelly twins were the famous example where one of them stayed earthbound and the other one was in orbit for about a year. And then they compared, when he came back, they compared their physiology and they compared, they looked at bone loss, they looked at a lot of factors to see what the differences were. And you have immediate bone loss, but well,
Immediate?
you have short-term bone loss that can
Okay.
be recovered if you're not up there too long.
Okay.
But after a longer period of time, this becomes irreparable. You never recover that full bone strength, and it's mainly in the weight-bearing bones, the femur, the leg bones, the pelvic girdle. Um,
The ones you need the
the
most.
ones you kind of depend on, your vertebrae, some things are pretty
Yeah.
important. So that's one of the problems. There was also some um, brain issues, and that was largely caused by fluid pressure. So we're used to walking around with pumping the fluid against gravity, pumping our blood, our lymphatic system, everything, all the fluids in our body against this force of gravity. So we're built to resist that. Now we're in space, um, everything gets confused. Your body doesn't know what's going on because it doesn't have to work very hard to pump the fluid. It pumps too much. You accumulate too much fluid in the brains. It causes pressure, and
Is this because of the gravity differential?
this is where you don't have they say microgravity because there's a tiny bit of gravity, but basically you're
Yeah.
on zero gravity. You're not expressing that force, or you're not
Right.
experiencing it. So that's another problem. They've had organ kidney problems. They've had a number of issues that living in space, living in zero or microgravity for an extended period of time. They don't know about children growing up. We would assume that the effects will be more severe because their bones
Yeah.
are growing.
Hmm.
Um, they may continue to grow, but they might be very fragile. Growing up in those microgravity situations. So for example, in my book on, well, I'm working on my third book, so sometimes I'm referring a book that's not published yet. It'll be out early in the year, and that's Outbound, um, Becoming Meta Mars. It's how we would settle Mars, how we would develop a large settlement on Mars.
Send me a copy of that when it's done,
Yeah,
please.
will do. I have it's essentially finished. It's got to go through all the editing process,
Yeah.
formatting, and I have artwork being done and so forth.
Hmm.
Um, there, I have in Mars. I have rotating called rehab orbiters. So the people living on Mars periodically there's a Martian base created by NASA. It's built out in lava tubes underground near Olympus Mons, which is just the largest volcano in the solar system. And they have detected a few lava tubes, and it's natural that there would be some around this volcano. So I put NASA base underground in lava tubes, but their Martian gravity is 38% of Earth gravity. So they can live and work there, but once a week or so they go travel up to the rotating rehab station, and it's like a spa, exercise, recreation of all kinds. They spend a week or so up there, then they come back down, and in that way, the attempt to mitigate the deleterious effects of less gravity are countered. We haven't done any studies on less gravity. We've done this. NASA's done the studies on microgravity, but as far as 1/6 or 1/3 gravity, they haven't experienced that because we haven't been to Mars and we haven't lived on the moon only a few days, and that doesn't count.
What would they be doing at that spa? Would they be working out? Is it like a
It would
gym
be
just to work
yeah,
those muscles? Or?
it would be yeah, rehabilitation implies social exercise, everything that would rehabilitate you. So there would be entertainment venues, there would be gyms, there would be dance studios, there would be. I have a little lake there. There would be swimming and paddleboarding and you know emphasizing exercise, and it would be at standard gravity, and so it would people would want to go there because it had nice restaurants and so forth.
Yeah.
So that's another issue is producing food. I really talk a lot about that because we're making some advances and we've all heard of the impossible burger, impossible beef, and impossible chicken, and improbable and unlikely, and so forth, whatever the names are. They are creating foods that resemble animal protein. So in space, we would be eating very little animal protein, if any at all. And if we were, it would probably be seafood or fish of some sort because they are.
Which tends to be the healthiest, I
Well,
think.
yeah, and but we definitely would not be eating beef, pork, or probably not even chickens. It's too inefficient a method of creating protein for our diet. So,
do you think there's long-term health impacts of that? Just the reduced availability of animal proteins.
yeah,
A lot of people would argue that that's an important part of our diet.
Yeah, I think the effects would be positive. I think.
Positive, you say?
Yeah, I think there would be because we can create the protein to replace animal protein. We can create that. We can do it in microbial tanks and grow and engineer microbes to produce different proteins. We can construct something that's going to be awfully similar to the meats we eat. They're also working on cloning tissues. It's in infancy, but you can imagine growing actual steaks without using
lab-grown meat, right?
Yeah, without using a cow. So those things are possible, but more likely, at least in the near term, would be genetically engineering bacteria, for example, to produce whatever you wanted to produce, and then harvesting those proteins and combining them into some sort of a meat substitute. We're going to have
so it'd be like those Star Trek meals that we see,
well,
right?
Not quite as quickly.
Yeah, right. Right. We'll get there.
So yeah, I think it's very possible. We're doing a lot of research with that kind of food production because we're raising cattle, raising pigs, and other livestock is first of all, it damages the environment. Secondly, you're concentrating. It's a monoculture, so you're concentrating animals of the same species in large amounts in close quarters, which is a recipe for developing pandemic viruses and so forth. And we look at especially truck crops like lettuce and carrots and radishes and so forth that grow in the soil. We're looking at increasing incidence of E. coli, and it's H147. It's a strain that is particularly toxic because it resembles salmonella, which is another toxic bacteria or pathogenic.
And this is all plausible because we were meant to forage and hunt. And so when we put it all into mass agriculture, we run into these problems, right?
Yeah, there's a number of problems with the way we are doing agriculture today on the planet, with few exceptions. That is, we're using a lot of chemical fertilizers. It kills
Mm.
they kill the soil. We're
Yeah.
using fungicides and insecticides that damage the soil, and the soil is a living environment, and it's important that it be maintained. It's also a carbon sump. So part of the reason that we have a CO2 problem in our atmosphere is emissions from burning fossil fuels, but it's also destruction of the structure of soil into dirt, and it's called desertification. So it's turning farmland into deserts. So all the microbes in the soil that have sequestered a lot of carbon, when they are destroyed, die, and they give off CO2. And you lose that whole environment to sequester CO2. So that's a different, kind of a different subject. But the solutions are being developed in universities largely, and today, on how to replace traditional farming and how to return some of that land to its natural habitat state. And I think we need to do that. We also need to reduce our population, but these are huge, huge problems. And so in my science fiction book, Outbound, the first one, it's post climate disaster. It's staged at about 250 years in the future,
Mm-hmm.
and about 4 billion people have died from starvation and wars and so forth. Migration has happened from the tropics to the north and south. Most
Mm-hmm.
of the land mass is in the north, so the migrations have been greatest up into, say, Siberia, Northern Europe, Canada, and in the south, all you have is Antarctica. I have a resort in Antarctica in the future. So they're trying to recover from all that we're doing today. And I took that stance because I believe we're on a track where we can't correct ourselves. So in my book I have a world government, a unified government, but it doesn't include the whole world. It's just the major countries have joined to form this central government in Reykjavik in Iceland, as a matter of fact. And
Why Iceland?
It's isolated. It's out in the ocean. It's hard for migratory hordes coming north to overwhelm them. It's easy to protect.
Interesting.
The planet politically is destabilized. There's the same with Antarctica. There's a subsidiary government in Antarctica, and but that also,
These are your visions for what you think is going to happen? Yeah. Okay.
Yeah, not happening. This is what I foresee in the future.
Yeah.
What could possibly happen.
I don't think it's a stretch, to be
Well,
honest.
I don't either.
Yeah.
So I look at today, and I look at the politics of today, the disunity in the world, the lack of coordinated action. And for example, Brazil is in control of most of the Amazon basin. The Amazon basin, looking at it from a naturalist view or an environmental view, belongs to the world, not Brazil. Well, Brazil takes a different look at it. It's our country. It's our borders surround much of it, and so they slash and burn and plant soybeans and try to graze cattle and so forth. Really poor land use. The soil in the Amazon basin is not adequate for that. So they bring in fertilizers, and pretty soon the farming fails and they leave back they leave excuse me, a wasteland.
Yeah. That desertification you
Yeah,
talked about. Yeah.
so it's going to become hotter and drier, and so these kinds of things should be under global control, over central control, and they're under national control. And our own country is, all countries are like that. They want to protect, they want to own their own property. There's a Native American belief, and other groups, ethnic groups, other groups of people believe the same thing: is that nobody owns the land. It's we become the land stewards. We
Right.
there,
Yeah, we've definitely left that
and we have
mindset.
definitely left that. So
Do you think a centralized government, I know we're going all over the place, but you raise some fascinating issues that would clearly be relevant up in space, and they're relevant here on Earth, seemingly. But do you think that the move towards a global government is politically dangerous in any way?
yeah, that's really hard to answer because you're assembling a lot of power at a point, and
Yeah.
and that's very dangerous. What I what I
I,
as
I worry about dictatorship,
yeah, I
totalitarianism,
mean,
that kind of
there's going
thing.
to be people who are vying for control. Well, we can kind of look at our own politics there.
Yeah.
And you just spread that out worldwide and say who's going to gravitate to try and gain power over the system.
Yeah.
Here's the thing about living in space that I see socially. Okay, first of all, the first people there would be scientists and engineers, and they
Mhm.
would be highly screened. They would have a skill set that was definitely needed to construct and maintain and get this program going. So there wouldn't be they would be a tend to be a more compatible group. I think they would have a similar mindset. So you probably wouldn't have the big social issues off the bat, but you would have to address them pretty soon when you started allowing general population to arrive. But here's the thing: every society has people who develop status through whatever the society values. And on Earth, most societies value power through wealth, and then it's displayed through mega mansions, yachts, owning islands, and something huge and tangible to show your power. And our societies grew up that way. I just was watching a movie staged in Heidelberg in Germany, and I remember a few years ago visiting Heidelberg, and there's a castle on the hill. It was destroyed and it's partially rebuilt, but they don't have the architectural drawings or plans or pictures of part of the section, so they don't really know how to rebuild it
Hmm.
because they don't know what the original looked like. But it's a massive castle on the hill that dominated the town. And this is all over Europe, and especially along the rivers, which were used for transportation. You had the dominant family business that had the castle, that had the big mansions, um, to display their power and their wealth. You wouldn't have that in space. You're not going to have a mega mansion. You're not going to have a huge yacht. So how are you going to display your social status? And so I
That's a
propose,
great point.
so I
That's a great
propose
point.
that you're going to have a stratification in society. It always develops. There are people who are just driven to um, work harder and attain more, and for whatever reason, there's a number of reasons, I suppose. And there are other people who sit back and do as little as possible.
Yeah.
So that you're not going to change, and you're always going to have people who seek power and status. So what would be that reward in these environmental situations on these colonies? And it would have to be social status. It would have to be social recognition. It would have to be you're looked up to because of your wisdom and your leadership and your contributions to society. Maybe you're an engineer that has designed a new type of habitat or whatever, and you're rewarded for that. In that you're allowed, there's a shortage of, say, real fish or lobster or crab. I mean, there could be those organisms, but they wouldn't be for general consumption. You couldn't raise that many. But perhaps if you were the equivalent of a billionaire, you might get a lobster dinner once a year.
Yeah.
Something like that that would
Hmm.
show your status within the community. The second thing is you in these environments that are close, it's pretty easy to travel, especially if you're, I call these clusters of habitats archipelagos, because I've used the word island. So an
Hmm.
archipelago is a group of related islands that are on a geologically related. So it's pretty easy to hop on a little spaceship out there and travel to another island that's close by, uh, because you're not overcoming any gravity issues, and they're fairly close. They may be, 30, 40, 50 kilometers away. Pretty easy jump, and you would be in zero gravity for an hour or two, maybe not even that. So it would be easy to go from one island to another within a cluster. So you would develop different environments. Say you had 6 habitats within a cluster. You would develop different environments in each one. They would have a theme. Um, and so for variety and recreation and vacation and the things that we socially need, you could take a holiday in another island. And experience a different environment. So the other thing is these societies individually in their island would be fairly small. Maybe 100, 200,000 people at the most.
I can't even fathom that in a
And,
space colony. Like that sounds like a lot of people to colonize in one space
well,
out there.
it's it's 20. You have to remember it's 20 kilometers long. It's 2 kilometers in diameter, and the
Mm.
whole inside surface is um, habitable. So you look up to the other side, and there's people standing on their, with their heads pointing down, if you could see them, but they're 2 kilometers away. So there's quite a bit of habitable space within one of these things. Um, there are some anomalies we'd have to get used to in a rotating cylinder. And for example, if you are standing there, you feel one gravity, you're not moving. You take a ball and drop it to the ground. You're targeting your feet. You want to drop it on your toes. The ball would depending on which way you were facing relative to the rotation, it would fall in a curve and miss your foot. So you wouldn't have any golf courses because you do a long drive down and you would hook or slice every time.
Yeah.
It'd never be a straight ball. So there's some things that are a little different.
So we have to give up golf, is what you're
Yeah,
saying.
we have to give up golf. Well, when I developed a colony on Mars, a habitat on Mars, there's a rift that's close to the equator. It's east of Olympus Mons, and then there are 3 volcanoes that are just east of Olympus Mons, and there's um, a huge rift, like make the Grand Canyon look like a toy or a model.
Mhm.
And it was caused by probably plate tectonics. It was early on in the planet's formation, and then suffered erosion when there was water on Mars. And it travels about 4,000 kilometers near the equator, and it varies in width up to 200 kilometers across, and 7,000 kilometers deep at the deepest point. So what I propose in my new novel that's coming out next year is that you would cover this, and you're living in the lava tubes, which is a pretty tight environment. It's not really open, but you would construct a roof over this um, Valles Marineris, and you would create a 1 atmosphere environment under this roof, and you would run it over a long period of time. You'd run it down the entire rift, and you could develop a society there of several million, multiple million people, because it's a huge area,
Hmm.
and you would have 1 atmosphere. You would create an earth environment there. You would have farming orchards. You would have some traditional uh, organic type farming. You still would not use chemicals or anything like that. And that brings up another point. In any of these off-planet societies, you have to be very, very careful about pollution. They don't have the capacity to absorb um, any kind of pollution. So everything would be really recycled, um, almost 100%. Your water.
So I have a stupid, like, environmentally ignorant question to throw at you. If you created pollution, could you just not somehow emit it into space, into like infinity?
Absolutely.
I know the environmentalists are going to come down on me for that,
Yeah,
but is that
yeah,
an
no.
option?
My wife came down on me when I started, doing surface mining on Mars, and she says, or mining the asteroids. She says, you mining them and breaking up these. I says, we're not talking about ecosystems. We're talking about inanimate matter. There's
Yeah.
no
Rocks.
environment to destroy.
Right.
Yes, you could bag up your trash and shoot it out into a decaying orbit into the sun or whatever you wanted to do. There's plenty of space
Yeah.
up there. However,
And I'm not encouraging that.
no.
I'm putting it out
However,
there.
it's wasteful because you need those resources that you've struggled pretty hard to get. Your carbon from the asteroid belt, your metals from the asteroid belt, most of the material you have, almost all of the material you would use to build this civilization would be materials that are already in space, either on the moon, on the Mars, or mainly in the asteroid belt, because you couldn't launch all that stuff from Earth, even from the moon. You could do some, but not enough to satisfy the need. So you wouldn't want to waste material, although you certainly could shoot it out of, you know, and but the main reason is you can't afford to. It's a lot
Okay.
of energy to produce whatever you're trashing, and so if you throw it away, that's another form of waste. You burned up a lot of energy, which brings up another problem: energy. Um, so we're assuming that energy you would get from solar, and most of it you would get from solar, but you could also make rocket fuel from water, and you could get water. There's plenty of water in the asteroid belt. You could get water there.
And that's clean, right? Water based rocket fuel?
Oh yeah, it is. But you could also use methane from Titan, one of Saturn's moons. They have a huge hydrocarbon ocean. It has methane, propane, probably ethanol. They have another a number of hydrocarbons in the sea that you could harvest and use that. You just burn it with oxygen, so that's a little more. You get a little more energy from that source than just hydrogen and oxygen. But hydrogen and oxygen rocket fuel separated from from water makes is a pretty good use because what you generate then is water again. So um, so you would develop the fuel you needed in space, and you would not want to waste any material that you could help. You'd want to be able to break it down and
Yeah.
use it. So there we get into microbes again. So you design your products, if they're metals, if they're ceramics, and so forth. There's a way to recycle those things. If it's carbon based, like a lot of our trash is today, plastics and paper and organic material from foods and so forth. If it's organic based, it took a lot of energy to make it to begin with, and you don't want to
Yeah.
waste it. So you would find ways using probably microbes to break down these materials into usable components. And in fact, that research has been going on for a long time. Back in a few centuries ago, when I was in graduate school, they were doing research on oil refinery grounds that were polluted with oil, crude oil, and looking for trying to isolate microbes that might break down oil.
Like a composting type
Yeah.
thing.
So and so that's been going on for a long time, and the problem we're facing on Earth with pollution are the forever chemicals, which have been developed to resist any kind of breakdown, like Teflon in our pans. And there's a lot of chemicals that are used that they used to have. Children's pajamas had to be sprayed with this chemical that was fire resistant, and that was a forever chemical. So when they found that out, they stopped doing it. But so there are some things you don't want to produce because they're very difficult to break down. But if you really had some toxic materials that created a problem, you definitely could get rid of them. And my thought is you would just put it in a decaying orbit around the sun and let nature take its course.
Yeah. That's pretty fascinating. Richard, I hate saying this, but we're out of time.
Yeah.
I had so many different things I wanted to ask you, and I didn't get to any of them because you shared so much wisdom and research. And so I'd love to have you back for another episode if you would join us.
Oh, sure. Yeah, we it's good, especially on a second visit, to focus on a particular area, because they're pretty broad-ranging topics. We're talking about
Yeah.
human civilizations and how we got here, where we're going, and all the implications. You
Definitely.
can't get more broad than that. So yeah, we can narrow it down definitely to a set.
That's great. We'll do a whole mini series.
All right.
How can people get more familiar with you and your books and your work?
I have a website that is richardandersonauthor.com, and that has a blog on it that has a lot of information. It has information on my books. They're on Amazon. You can get you can go on Amazon, and they allow you to read a sample of the book, and you can get a little bit of information that way. The science fiction book is available hardbound, softcover, ebook, and also audio. So some people like the audio. They can, if they have a long commute, they can listen to a book. I have one particular doctor friend who commutes a lot, and he just goes through audiobooks like crazy. So I decided to publish that one also as an audiobook. But my blog has a number of articles. It has some of these recordings on it, and there's quite a bit of information there.
Okay. We'll make sure to include that in the show notes. And thanks a lot for being here and talking with us today. Really enjoyed it.
Oh, I did too. Thank you much. Hopefully, we'll see each other in the future.
Absolutely. I'm going to hold you to it.
Okay.
I'm going to hold you to it. Thanks for joining us. We really appreciate you guys. You can always find us at mikecpodcast.com or wherever you get your podcasts, and drop us a comment. Tell us what you think of space colonization. Do you think it's realistic? Do you think we can do it? Do you think we could someday live in space, or are we stuck down here on Earth? We love hearing from you guys. And until next time, thanks a lot, everyone.
The Mike C. Podcast.